So today we're going to go ahead and we're going to take the special right triangles, we're going to take them a step further. What I want you to think about as you work through this are all of your rules for radicals, because this is where folks seem to have the hardest time. Now remember yesterday when we started talking through this, I said that what I like to do here is to go ahead and label the triangles when we start to give us an idea of what those ratios are. So if we look at number 1, it's clearly a 30, 60, 90 triangle, which means we have x root 3, and 2x. So then we can use this information to solve for m and n, right? So in this situation, m is equal to 2 times 124 root 3, which would give us 248 root 3. And then n is equal to x root 3, which would give us 124 root 3 times root 3, which would give us 124 times 3. Because remember, root 3 times root 3 is root 9, which simplifies back down to 3, which gives us 372. So that allows us to solve those. Now let's look at the second one over here. For number 2, it's a 45, 45, 90, or an isosceles right triangle. So again, in this situation here, we have the ratios of x, and x root 2. So again, we can use this information to solve for this. So we know that b is going to equal to x. So we know that b simply equals the same thing, 427 radical 2 over 2. A is going to equal to x root 2. So that's going to give us 427 root 2 over 2 multiplied by radical 2. And again, the radical 2 times radical 2 gives us radical 4 over 2, which is simply 427 times 2 over 2. The 2's can cancel, and so it's 427. So again, this is just more of a process of taking your time as you go through these, and you'll be able to work these out. Now they get a little bit more complicated, so we're going to go to the next one here. And on these here, these again are set up the same process, but now we have to go from one triangle to the next. Sometimes it's easier to take the triangles out. For example, it's easier to take this first one out. I'm just going to redraw here. This is our 45, 45 right with 8 radical 6. Sometimes it's easier to do that to just begin working through it. And if that's something you find easier, you should go ahead and do that. And then we can go ahead and write our ratios. We have x root 2. That again just reminds us of how these work, which means the missing length that connects these two triangles is 8 radical 6 times root 2, which gives us 8 radical 12. Now remember, 8 radical 12 we need to simplify. We simplify that to 8 radical 4 times 3, because 4 is a perfect square. You take that 4 out and we get a 2, which gives us 16 root 3. So what we now know is that this missing piece here that we need is 16 root 3. Well, again, this is another 45, 45 right, so that means this second side is also 16 root 3. And remember, the x is actually, in terms of the ratios, is x radical 2. So again, we're going to go ahead and take x radical 2 and substitute in 16 radical 3 times radical 2, which gives us 16 radical 6 is for this x here, for the x in the equation. Sometimes it helps to think of this number. You might want to cross this out sometimes and do y, or you can use here, do this as y root 2. In other words, what you want to think about is how can we set that up in a way that you don't accidentally use the wrong numbers. Okay, let's look at the next example to our right. So example number 4. This is, again, same process. I always find it easier, at least for the way that I visualize things, to draw this one back out here. So we know this is the 60, 30, this is 9, and since we know that that's 9, then we also know that we're going to have x root 3, and 2x. Again, it just simply helps us to visualize the next step here. So we get 9 equals x root 3. And to solve this for x, we need to divide both sides by radical 3. And remember, you can't keep a radical 3 in the denominator, so we're going to multiply the numerator and the denominator by radical 3 here, which gives us 9 radical 3 in the numerator and 3 in the denominator, because radical 3 times radical 3, these right here, becomes radical 9, which is 3. And then we can reduce here, and so we end up with x equaling 3 radical 3. So that gives us this missing piece here, 3 radical 3. We just erase that here. I don't want that extra line. So it gives us, again, this is 3 radical 3 here. So if we now look at 3 radical 3, well, in a 45, 45, 90, right, 3 radical 3 is part of the relationship and that we talked about before. I'm going to do as I suggested, by the way, right now, and instead of writing these as x's, I'm going to write them as y. It's y, and y root 2. And the only reason why I'm doing it as y is because there is an x here and I don't want to mix them up. So we get 3 radical 3 equals y radical 2, and you could have used x radical 2 here. There's nothing wrong with it. It's just a habit that if they're using x in the problem itself, I want to use a different variable. So we're going to divide by radical 2. Now remember, you cannot have that radical 2 here in the denominator. So I'm just going to go up here just for a little more space. We're going to do 3 radical 3 times radical 2, multiply both parts by radical 2 to move that up, right? And we end up with 3 radical 6 over 2, which is the value of y, which of course now is also our value of x, because that's the one we're solving for. So again, these are more complicated than the ones we did yesterday, but the process is the same. It's just a matter of taking it step by step as you work through it. This is the information that's going to be on the work that you're going to be doing today in class. And hopefully this, for these 4 examples here, really helped to prepare you.